In this section, we're going to look at conversion of units. In physics, quite often we have to convert from one unit to another. We do that by using a ratio that we call the conversion factor. So let's define what a conversion factor is. A conversion factor is a ratio between two units equal to 1. This is a ratio between two units equal to 1. Let's demonstrate this by means of examples. Suppose we want to convert 2 kilometers to meters. Okay, so first we have to establish a relationship between kilometer and meter. K stands for 1,000, so kilometer simply equals 1,000 meters. We can get two conversion factors out of this. Either we have kilometer divided by 1,000 meters equal to 1, or 1,000 meters divided by kilometer equal to 1. Okay, but since kilometer is at the top, we have to pick the conversion factor where kilometer is at the bottom. So remember, this is 1, so we're just multiplying by 1, we're not changing anything. Okay, so I'm going to pick this one because kilometer at the bottom. All right, so we've got 1,000 meter divided by kilometer, and kilometer goes away, and we get 2,000 meters. Another example, let's say we want to convert 2 meters per second to kilometer per hour. Okay, so in this case we have to do two conversions. We have to convert meter to kilometer and second to hour. Okay, kilometer is equal to 1,000 meters, so we're going to have two conversion factors, either kilometer over 1,000 meter or 1,000 meter over kilometer. They're both equal to 1. Okay, but since meter is at the top, we have to take the ratio where meter is the bottom. Okay, so we cancel it out. So we're going to use this conversion factor, and then we have to convert second to hour. We know that hour equals 60 minutes times 60 seconds. Okay, that is 3,600 seconds. So you can get two conversion factors out of this, either hour divided by 3,600 seconds equal to 1, or 3,600 seconds divided by hour equal to 1. Now since second is at the bottom, we have to pick the ratio where second is at the top, so we're going to pick this one. All right. So going back to the problem, 2 meters per second, we're going to multiply by these two conversion factors. You've got kilometer divided by 1,000 meter, and then 3,600 seconds divided by hour. So meter goes by meter, second goes with second, and 3,600 divided by 1,000 is 3.6. So you get 7.2 kilometer per hour. Another example, let's say we want to convert 10 centimeters squared to meter squared. Okay, so first we have to establish a relationship between meter and centimeter. We know C means 1 over 100. Okay, centimeter, that is 1 over 100 meters. So that gives us the following relationship: meter equals 100 centimeter. But this relationship is a relationship in the squares, so we have to square both sides. So we've got m squared equals 100 centimeter squared. That gives me meter squared equals 10 to the power of 4 centimeter squared. We can get two conversion factors out of this, either meter squared over 10 to the power of 4 centimeter squared equal to 1, or 10 to the power of 4 centimeter squared divided by meter squared equal to 1. But since centimeter squared is at the top, we have to pick the conversion factor where centimeter squared is at the bottom. So we're going to pick this conversion factor. So we have 10 centimeter squared times this conversion factor, which is equal to 1 m squared over 10 to the power of 4 centimeter squared. So centimeter squared goes with centimeter squared. We get 10 divided by 10,000 is 10 to the power of -3 meters squared. Another example. Let's say we have 5 kilogram per meter cubed, and we change it to gram per centimeter cube. So first let's establish a relationship between kilogram and gram. Kilo means 1,000, so kilogram equals 1,000 grams. So from this we can get the following conversion factors, either kilogram over 1,000 grams equal to 1, or 1,000 grams divided by kilogram equal to 1. Now since kilogram is at the top, we have to pick the conversion factor where kilogram is the bottom, so we're going to take this one. And then we have established a relationship between meter and centimeter. We just saw that meter equals 100 centimeter, but the relationship is between the cubes, so we have to keep both sides. We got meter cube equals 100 centimeter cubed. That is meter cube equals 10 to the power of 6 centimeter cube. We can get two ratios out of this, either m cube divided by 10 to the power of 6 centimeter cube, or 10 to the power of 6 centimeter cube divided by meter cube equal to 1. Now meter cube is at the bottom, so we have to pick the ratio where meter cube is the top, so we're going to take this conversion factor. Okay, now going back to the problem, we've got 5 kilogram per meter cubed. We're going to multiply this by the two conversion factors. We have 1,000 grams divided by a kilogram, and the other conversion factor is meter cube divided by 10 to the power of 4 centimeter cube. Okay, so kilogram goes with kilogram, meter cube goes with meter cube. We're left with gram per centimeter cube. So this is 10 to the power of 6. So you get 5 divided by 1,000. So this would be 5 times 10 to the power of -3 gram per centimeter cubed.